Ravi, thanks for having me.
Thank you.
So what's MQTT and what's the role that HiveMQ is playing here in the UNS for ProveIt session?
Sure. So quick story. MQTT started in oil and gas in the late 90s because oil and gas had like remote assets that they want to try to connect to the enterprise. But guess what? The connectivity is bad. The bandwidth is bad. So the regular ways of networking did not work. So MQTT originated. It was actually co-invented by Arlen Nipper, who's here.
Yeah.
Two aisles down.
I did an interview with him.
Yes, and Andy Stanford Clark. As a publish-subscribe model, which what it is like, hey, whatever little connectivity I have, right? Maybe satellite or like some cellular connectivity, I just need to publish. I just need enough to be able to publish the data to like a centralized broker. Maybe I just need like maybe 100 kilobytes or something. And then once the data is, then maybe a temperature data point or a pressure data point, and then the broker can then communicate that out to other clients that need that information, like maybe a remote monitoring application or some kind of like a database and things like that. So it's very efficient in the way it gets the data. It's real time, and it has like reliability built into it. That's
Very
what
good.
MQTT is. Yeah.
Very good. And HiveMQ
Yes.
is a broker
Yes.
that supports the
Correct.
technology.
Once it became open source, HiveMQ came along in 2012, and the company created this product based on the open source software that's MQTT. But then we wanted to ensure that we differentiate ourselves. One of the ways we do it is we are enterprise grade, which means like high number of connections. Like from a scalability perspective, we can go to millions of concurrent connections at the same time. Perfect. We provide high reliability. We build on the reliability that's already built into MQTT, and then we do high availability. Like for example, if you're trying to monitor plants, right? What if like the broker goes down? What happens to production, right? 1 hour of production loss, what does that mean, right? Mm-hmm. So if that cost is going to be high, you want to have high availability, which means that a backup broker can take over. So we have clustering and technology that ensures that the broker is always available, packets are not lost.
Yeah. So if we have what we call the brownfield, right?
Yes.
So
Yes.
you know that not every new factory with
Correct.
new devices are MQTT enabled,
Of
right?
course. Yes.
IIoT ready, as I
Right.
call it.
Uh-huh.
So how can we do a brownfield conversion
Yes.
to OPC from OPC
OPC,
Wave,
right.
from
Yes.
any Rockwell PLCs
Right.
that you have?
Right.
Is there a HiveMQ product today that we can use?
Yes. Thank you. Thanks for asking. I was going to add that. So we have the central broker, which is great, but it needs the data to be in that MQTT topic structure format. So one of the additional products that we have launched is called the Edge Gateway, which is a small footprint software that can be installed on virtual machines. It can be installed on like small appliances. Mm-hmm. The job of that is to take, say, OPC data or tags coming in the OPC format or Modbus or Siemens S7 or Rockwell Ethernet IP, convert that to MQTT topics and bring that into the broker. It also serves as like an edge gateway. Edge broker, because you want to kind of like collect the data from different aspects of your edge and then consolidate that, right? And then do store forward if the connectivity is lost, for example, and when the connectivity is reestablished, you can resend the data. Those are the things that we are able to do, so that like you have that unified namespace. Maybe I should also explain what unified namespace is, if that's okay with you.
Go ahead. Most of the public should know about this time, but it integrates with the unified namespace, and you can do that mapping where you tell the hierarchy and then you map that old data that it doesn't have that structure to it. Right.
So in the world of industrial world, in manufacturing, there is something called ISA 95, and then like when you bring in MQTT data, you want that context, right? It's not just a sensor data point. It's not just a pressure data point. It's like where it's coming from. That's what we call a semantic model. So one of the things that UNS allows you to do is have a context around this data. So imagine you have like a library, right? And you are trying to find a book in the library. You need to go to that library indexing system that tells you, hey, if I want to go to action books, I'm in this section. If I want to go romance, if I want to go comedy, I want to go in this section. So this is basically that index card that allows you to get to the right data that your business needs to make decisions, so that you can then say, okay, you know what, this alarm is triggered, or this set point is triggered. What do I need to do for in that scenario? That's what unified namespace is. Yes.
And you can organize that.
You can organize that in MQTT because UNS is like, and this term was actually coined by Walker Reynolds, whose conference we are in this week, right?
Right here.
It needs to be edge driven. It needs to be short. and it needs to also kind of like be real-time data, because UNS is like kind of like a snapshot of your business status at this moment, if you will, right? It's not history.
Time. That's right.
Correct.
That's right.
It's
the minimum technical requirements.
Exactly. So that's what it is, right? If you want history, you go to a historian. If you want like to do database calculations, you go to a database. But UNS is like pulling all of this data, your machine data, your MES data, and your other pieces of information to give you that true status of your business, so that you can use all this data to then build out your remote applications, for example, or in the world of AI, because everybody's talking about AI, right? But if to build AI models, you need like real-time, good quality, contextualized data. And that's what UNS helps you build.
Yes. Big announcement,
yes,
right? We had a big announcement here. We don't know how you guys were able to hide that secret, right? But now we can talk about it. It's HiveMQ Pulse.
Yes.
So now we're talking about how to get that data into a unified namespace in a hierarchical model.
Right.
But what we always need to do is metadata and enrich that payload and bring it context, right?
Yes.
So tell me a little bit about HiveMQ Pulse.
Yes, so HiveMQ Pulse is kind of like a new service that we've launched, basically which piggybacks on all of the components that we already have. We have the edge, we have the broker, and we have the extensions, which talks to different applications and cloud applications and things like that. But the thing is, like when we talk about unified namespace, a lot of companies are like, oh, I have a unified namespace here on the edge. I have it on this location. I have it on this location. But the true meaning of unified namespace is there on one location, right? So the goal of Pulse, single source of truth. The goal of Pulse is like, you don't have to bring all this data to a single location if you don't want to, but how can you actually query the necessary information and bring all this data to a single location where you can start looking at all of your data, you can start querying it, you can like get history and things like that. That's what Pulse is all about. It is a quick and easy way through clients and through agents to pull the data into a single location and then contextualize it in a format that makes sense for you without having to move data across from edge to cloud to other places. So that's a new product that we have. We actually have like a preview that we launched as of yesterday. So please do have your users also sign up for the preview so they can test with it. The launch will happen like sometime later this year of the product.
Very good, very good. I will be one of the testers myself, and hopefully we're going to do a live video where we're going to shoot a video showing the implementation. Okay. Thank you very much, Ravi, for talking to me.
Thank you for your time. I appreciate it.
Good luck.
Thank you. Bye-bye.
Bye-bye.
Tupinix. Smart Factory Solutions.